So, Jason, in the world of post-quantum cryptography, we have these new algorithms from NIST, and we're replacing RSA or ECC with ML-DSA and ML-KEM, replacing one thing with two things. What's going on there?
Yeah, you're replacing key exchange with one thing and signatures with one thing.
Right.
So it's two things with two things.
Right.
So, by the way, most key exchange right now is ECC Diffie-Hellman, right? So in other words, ECC is also doing the key exchange, but it's also a very, very, very popular, ECC DSA.
Sure.
Right. So in other words, the digital signing algorithm.
Yeah.
So first of all, let's talk about those terms. I think we've talked about this before, but it's worth bringing up again. I really like the naming conventions that NIST is using.
Yeah.
Once it comes off of its informal name, like dilithium and all this other stuff where it began.
Yeah.
The naming conventions that they started to use were basically the type of math, ML,
Yes.
module lattice,
Dash.
and
the purpose.
digital signing algorithm. So the math dash purpose.
Yeah.
Great naming convention because it tells you a lot in a very short number of letters, right? And so ML-KEM is a lattice-based key exchange method.
Right.
And the digital signing algorithm is also lattice-based as well. What is that telling us? Well, right now, there's a whole lot of places that you'd be surprised where there is a post-quantum key exchange going on. Boss Westerbon was on to announce to the world, hey, we've implemented over at Cloudflare, and as a great big CDN that puts a lot of stuff on the edge at the internet that you probably are browsing on a daily basis. A lot of their key exchange mechanisms going on behind the scenes because they obviously need that as part of their infrastructure is using ML-KEM or variations that are pretty close in terms of concept. Boss was on and explained exactly what he was doing. So, other places where you'll start to see key exchange mechanisms. I experimented recently, just myself, creating an MCP server that used a certificate to authenticate an agent. And that actual authentication procedure needed a TLS handshake. Part of that handshake is a key exchange mechanism. And I actually used the hybrid of ML-KEM 768, I believe, with one of the X256 curves, right, as part of the hybrid. And so you get to see where that's really, where you as an enterprise might use that. You're probably as an enterprise going to use ML-KEM sometime in the future as part of your normal TLS 1.3 handshake.
Right.
For everything else, which kind of comes second, right? In terms of the move towards a quantum resilient world, that's when the signing algorithms are going to start coming in.
Yeah.
So why signing? Signing, by the way, is really what's going on behind authentication. It's really going on behind things like, putting a spiffy identifier on a cert uses signing. And so signing is used so often in a lot of people think of document signing, code signing, when in reality, signing of certs it themselves is a major thing.
Sure.
And so therefore, ML-DSA going, as the popular currently touted standard for quantum resilience is that. But it's fundamentally different in terms of when you enact it, when you use it, compared to ML-KEM, which is happening at the very specifically at the key exchange mechanism. So, in terms of, I can say those words, and I think for everybody else who doesn't want to think about it so technically, it really comes down to there's a lot going on in your PKI, and there's a lot of primitives that are important, right? I think people generally understand hashing. It's kind of like an encrypted digest that's one way, and it has a lot of really important benefits to us. Blockchain is based off of it. Our own CT logs, of which Merkle tree certificates in the future are based off of it. We'll be talking a lot more about hashing as a cryptographic primitive that's in the future, because it's going to become a lot more important to all of our lives. But for now, it's important to know that you as an enterprise will be messing around with ML-KEM whenever you're messing with TLS 1.3. And also you'll be dealing with ML-DSA whenever you're dealing with actual certificates, because the certificates themselves are going to need to be signed. And even Merkle tree certificates themselves are a signed certificate that is then signing itself a Merkle tree.
And the KEM, since it's a key exchange, is external to the certificates. I can implement ML-KEM with traditional RSA certs.
Yes.
The signing, the DSA, is the part that's built into the cert, and that's ML-DSA.
100%. ML-KEM is not the cert. It is things that are happening before that can even occur.
Right.
And you're absolutely right to say, because I just experimented with, as I said, the MCP server that I built. I created two versions. One, a full PQC end-to-end authentication sequence. But I also created one where it was an ECC signed certificate rather than. Got it. And it did absolutely work with TLS 1.3 using ML-KEM 768.
Yeah, there you go. All right.
Thanks, Tim.